Ready? So, and guys, go ahead and take some notes so you know this. Okay, a lot of people, when they draw Lewis dot structures, they draw the Lewis dot structure for every element, and then they move them close together so that the dots are shared or not shared and all that kind of stuff. And that might have worked when you were drawing very simple molecules, but that will get frustrating in a hurry when you start to draw more complicated ones. So I want to show you this other way to do it. We're going to start with a very easy molecule, water. Okay? Now, what I do is first add up all the valence electrons in your atoms. So y'all tell me how many valence electrons are in hydrogen? One. And you have 2 hydrogens. How many valence electrons are in oxygen? 6. How do you know that so quickly? It's in the 6A group. Okay? All right, so how many total electrons do we have? 8. Okay, so that's the first thing. Add up all your valence electrons. Second, you're going to pick your central atom. Usually it's the oddball. What would be the central atom here? Oxygen. The other thing is this. Can hydrogen ever be a central atom? Why not?
Because it's the small.
Not because of that. It can only have 2 electrons. So if it only has 2 electrons, that's just 1 bond. So hydrogen can never have more than 1 bond. Does that make sense? Okay. So you pick your central atom and then stick your other atoms on it with a single bond. If it's part of the molecule, it at least has a single bond. Okay? Now, count up how many electrons you've used so far. Remember, a stick represents a bond, which represents 2 electrons. So this is 2, 4. We've used 4 electrons. How many do we have? 8. So we have 4 more electrons to use. And here's the trick. You distribute them outside, on your outside atoms, and then on your inside. So let's first look at hydrogen. Okay? Does hydrogen need any more? No, they're happy. Okay? So if they're happy, we move on. Okay? So we've got 2, 4. We've got 4 more to use. Here's your 5 and 6, 7 and 8. Okay? Now, we have to stop because there's 8 electrons. Is oxygen happy?
Yeah.
Yes, it has an octet. So, voila, we've got our Lewis dot structure for water. Okay? Let's try one that's got a little bit more to it. Carbon tetrafluoride. How many valence electrons does carbon have?
4.
How many does fluorine have? 7, and there's 4 of them. So this is 28 and 4 is what? 32. Okay? If you're falling asleep, go ahead and take notes. This will help you stay awake. So you've got 32 electrons. What is going to be our central atom? Definitely carbon. And so now, just attach all the other atoms to the carbon. How many have we used so far? 2, 4, 6, 8. Right? Now, I'm going to put them in with red just so you can see the other ones. We've got 32 to use. We've used 8. So I'm going to keep counting. 2, 4, 6, 8, 10, 12, 14. Can I keep putting some here? No, it has 8. So I got to keep on going. 16, 18, 20, 22, 24, 26, 28, 30, 32, and I've run out of electrons. So now I stop, and now I evaluate every atom. Does every atom have 8 electrons around it? Fluorine does. This fluorine does. This fluorine does. So does this one. And so does carbon. If they're in a bond, they get to count those. 2, 4, 6, 8. So this molecule is good. Last one to consider, because sometimes they're not all good. Okay? Let's do SeO2. How many valence electrons in selenium? 6. It's in the 6A group. How about oxygen?
6.
And there's 2 of those. So how many total electrons? 18. What's our central atom? Se. It's the oddball. Let's connect an oxygen here, connect an oxygen here. How many electrons have I used? 2, 4. I'm going to keep counting. Start with the outside in. 2, 4, 6, 8, 10. That's happy. 12, 14, 16. That's happy. 18, but I have to stop. I don't have any more electrons. This was happy, but is selenium happy? No. So now I can't use any more electrons, but I have to get selenium with 8 as well. Let's try this. Let's take these electrons, which are non-bonding, and let's keep them with oxygen, but let's move them to the middle. Okay? Now, is this oxygen still happy? Yes, 2, 4, 6, 8. Is selenium now happy?
Yeah.
2, 4, 6, 8. Now it's happy. And is this oxygen happy? 2, 4, 6, 8. Just to note, guys, it does not matter whether you put the double bond over here or whether you put it here. We'll talk about what that means later, but you can put it in any position that works. Okay? Thanks.